identify a linear equation using the X and Y-intercept. Let's read together. 1, 2, 3. I can graph and identify a linear equation using the X and Y-intercepts. Now, last week, we introduced linear functions. Today, we're moving on to linear equations. And we're not going to need a FAIR model. Some of you are asking, wait a minute, Mr. Q, but aren't we moving on to the new concept of linear equations? Yes, but let me show you why we're not doing a FAIR model. Let me show you from what we did last week. Here it goes. Look on your screen. Last week, we did linear functions. Remember that? Yeah. Today, we're doing linear equations. Let me go back to the previous linear functions. Linear equations, linear functions, linear equations, linear functions, linear equations, linear functions, linear equations. Just about the same, but there's a couple of things that change. Linear functions, linear equations. Talk it over with your neighbor, see what's missing or what's added. All right, Lisa. What is the one thing that you notice on linear equations? One of the hashtags is missing, the critical attributes, which was exactly for one input, there's exactly one output. Remember that one? That's what makes a function. Now, why didn't we include it there? Look at the examples. Out of those examples, which one that we included now made us take off that hashtag? Think about it. Look at the examples. Which one of those made us take away that hashtag? Talk it over with your neighbor. Tell them why and which one. All right, let's see. Oh, sorry. Amelia. Which one of those makes it made us take off that critical attribute? Y equals -3 is close. Remember, y equals -3, the graph looks like this. Do any of the x values repeat if I graph this line? No, because each point is a different x. But look at this, x equals 4. What are the x values for all these points? The same value, right? Everybody with me? Is everybody following? Yes? Here to refresh your memory, we plotted some points like this. Remember that? And we said this is not a function because if I write the coordinates for all those points, the same value for x, but a different value for y. Remember that? That's why this was not a function, and if we include it as an example, that's why we cannot have that extra bullet. Everybody with me? Yes, Mr. Q, we love this. All right, good. Copy these steps, please. Steps 1 through 5. It says, steps. Use the cover-up method to eliminate one variable. Step 2, solve for the remaining variable. Step 3, repeat steps 1 and 2 for the other variable. Step 4, plot your intercepts. And step 5, graph your line. Copy that, please. So the steps that I just gave you is to graph a line using the X and Y intercepts. However, I do want us to identify the X and Y intercepts, what they are. Here's the definition. Write these down, please. If you have your colored pens, use those. It says, A Y-intercept is where the line intercepts or crosses the Y-axis. The X-intercept is where the line intercepts or crosses the X-axis. Write that down, please. And since we're getting into graphing, make sure you do have your colored pens. If you don't, over the Thanksgiving break, make sure you wash a car or clean the house or whatever. Get some, get a couple bucks.
Washing a car? I washed the wall.
Well, it should be that you're grateful and you're giving thanks and you're washing it for free.
No.
so then the $2. So the $2 will be extra, and you can buy a pen. There you go. What? Okay, here we go. Get this, now that you wrote down the definitions on your Cornell note, get this play sheet in front of you. We're going to go over examples at Q and super Q. Okay, here it goes. So, oh, sorry. I'll leave it up there. It's up there. So example Q says, find the X and Y intercepts. Find the X and Y intercepts. And here they give us a graph. And you have that in your play sheet, yes? Okay. Look up to the screen, please. So I'm going to go over this really quick, writing utensils down, and then you can copy later. Here it goes. According to the definition, the Y-intercept is the point where this line crosses the Y-axis. I'm going to highlight the Y-axis. Here it goes. Here's the Y-axis. And does everybody see where that line crosses the Y-axis? Yes, I'm going to place my point. I'm going to use red. And that point has a coordinate, 0 of X, 1 of Y, and that is known as the Y-intercept. On the same token, the definition for the X-intercept says when this same line crosses or intercepts the X-axis. Here's my X-axis. Does everybody see where it intersects? Yes, about right there. I'm going to do that in blue. That has a coordinate. That is -2, 0, and that's known as the X-intercept. Did we find the X and Y intercepts? Yes. Copy that, please. Yes.
I know, I was like,
for the Y-intercept, it's always going to be 0 starting it, and then it's going to end with 0 on the end.
Yes, Noelle made an observation. She said, Mr. Q, so for the Y-intercept, the coordinate always starts with 0 for the X. That is correct. And the X-intercept always ends with 0 at the end. That is correct. Yes? Okay. That was example Q. Let's go over example super Q. Here we go. Oh, no yet? Okay, sorry. There? All right. Example super Q. I want you to get your red pen, place a point or a red marker. Place the point where the line crosses the Y-axis and give me a coordinate and label it, please. That's if you have it.
I don't have it.
For example, super Q, turn the paper over. For super Q, I want you to place a point on the Y-intercept. Write your coordinate and label it. Do the same thing for the X-intercept, but with blue. Write your coordinate and label it. All right, let's see. Did everybody see that it crosses at For the y-intercept, it crosses at positive 5, and the coordinate for that one is 0, 5, and that's my y-intercept. So far, so good? My x-intercept, the x, it crosses at 6, so my x-intercept is 6, 0, x-intercept. Hands if you got that by yourself, okay? All right. So we got this, yes? All right, so this next one, look up to the screen. I'm going to send you this to your iPad. Right now it should show, but you can't write on it. But I'm going to send you the one that you can write on it. And I want you to sketch or graph a line. Here it goes again. I want you to sketch a line. That some of in the other colors it has any line, Mr. Q, any line as long as it's a straight line. After that, you need to identify the x and the y-intercept of that line that you drew. Is yours going to look the same as others? No, because it's your line. So don't look over your shoulder. Just do your own work at the end. Press send so I can see what you did. Everybody with me? All right, here we go. I'm going to send you the screen. And there it is. And go ahead and draw your line. Identify the x and y intercepts. Write your coordinates and label it. Ready, go. We're over. So we're going from here to the back where the 4 coordinate planes are at. I want you to copy this next one at the top left. At the top left. Yes, sir.
So the one you just showed us, where it says that, what do you put for the y?
It doesn't have a y. Because it never, just that. Yeah. All right, here we go. It says example 1. Graph the following line using the x and y intercepts. Copy the equation 5x plus 2y equals 10. I'm going to go over that. Matthew, go.
I was going to ask if we had a copy.
Yeah, only copy the stuff in black text.
I started erasing instructions.
All right, here we go. Writing utensils down. Look up to the screen. So, like I said, last week we graphed using input-output tables, yes? Here goes something that we call the cover-up method. Look up. Writing utensils down. Guys, you guys are the ones that are staying after school, not me. I have to stay for tutoring, so here it goes. So, cover-up method. Why is it called cover-up method? Because if you're, from where you're sitting, take your thumb, cover up the 5x. What do you guys see? 2y equals 10. Solve for the remaining variable. Divide by 2. Y equals 5. Guess what? That's my y-intercept. Coordinate is 0, 5. Y-intercept. Now get your thumb and cover up the y value. What do you see? 5x equals 10. Divide by 5. X equals 2. That's my x-intercept. And our coordinate is 2, 0. X-intercept. And all we have to do is graph our line through those 2 points. I don't know. I'm just talented like that. Technology. All right. Are we good with this? Notice that on the first examples, it was just to identify the x and y intercepts. Yes?
Yeah.
On this one, you graph the line using the x and y intercepts. So, you copy that at the top left. Now, on the top right, copy example 2. See if you can do this one by yourself. Example 2, y equals 3/5 x plus 3. You don't have to copy the instructions anymore. You already have them. Example 2, y equals 3/5 x plus 3. I know. Let's do this one together. Here we go. Cover-up method. Which one do I cover up first? 3/5 x. All right. And what do you see? So y equals 3, 0, 3. Y-intercept is my y-intercept. There it is. All right. And now I cover up the what? The y. If I cover up the y, that means there's nothing there. Is that correct? If there's nothing there, then this becomes what? 0 equals 3/5 x plus 3. Does that look familiar? Yeah, we can solve that. So where do I start? Subtract 3 from each side. We're left with -3 equals 3/5 x. To leave the x by itself, how can we get rid of this 3/5 right here? Times the what? The reciprocal, 5/3 times 5/3. So this becomes -15/3 equals x. And what is -15/3? -5 equals x, or -5, 0, that's my X-intercept, and that goes right there. And there's my line. Yes, Felipe. No, go ahead. No, go ahead. No, go ahead. All right. How we doing? Yes? All right. Show me with the fingers how comfortable you are with these. 1 being the lowest, 5 being the highest. Got some 4s, 5, 10s. I got a 23. Bam. 4, 5. What? What's this? What's this? Bam. But bam. I mean, that's mad at me as well. All right, so we got that, yeah? All right, so check this out. Now, I'm going to forward it. Yes. Did you ever see what we did? Oh, how did I get y equals 3? I covered the x.
Oh, okay.
Yes? Okay. Now, I could give you some more problems that look like it, but we already did this kind. We already did this kind. I want to get to this kind. Look up. Look at this one. It says, turn your paper over. I know, right? Turn your paper over to example 6 in the back. It says, Mr. Q can run the 200-meter dash in 25 seconds. Be nice. Hey, believe it or not, when I was in high school, I was pretty fast. So, unless you run your 2 miles in 13:03 like I used to, 2 miles in 13:03, then exactly. Here we go. Yeah? Here it goes. So, it says, Mr. Q can run the 200-meter dash in 25 seconds. The function f of x equals 200 minus 8x gives the distance remaining to be run after x seconds. Graph this function and find the x-intercepts. What does each intercept represent? So watch. I'm going to write the function. F of x equals 200 minus 8x. Now today we haven't been using function form, have we? Because we are in what? Linear equations. So how can we change this to a linear equation? Talk it over with your neighbor. How can we change this to a linear equation, not a linear function? All right. Noel.
Change the x to an n.
If we change the x to an n, it's still in function form. Hannah.
The function of any number is always on the y-axis, so we can just change it to y.
So changing the function, she said changing the function to the y value, and that becomes y equals 200 minus 8x. Does that look like a linear equation? Yes.
No, you have to change the entire thing.
Hold on. Now, I had mentioned this last week when we covered functions, that we can write this as a two-variable equation just by exchanging the function notation to y. Everybody with me? Now, at this point, look up. I need to graph this. Which graphing method do you want to use? The input-output table or the cover-up method? Okay. So that's one of the things that I want to make sure that you understand. I'm giving you the different methods so you can choose which would be something that would get us faster to the answer that we want. So here, what do I cover? Negative 8x. Therefore, what is our y-intercept? So I'm going to place this right here, 200. Now I'm going to cover up the y, and that gives me 0 equals 200 minus 8x. Let's solve this. Subtract 200. We're left with negative 200 equals negative 8x. Yes? Oh, no, I know. That one you're going to do by yourself. The Jordan one. Here goes. Divide by negative 8, divide by negative 8. 25 equals x. That goes right about, I'm going to put it right there. And I went by 5, 10, 15, 20, 25. All right. So question. I started my race about right here, and I ended up right there. Tell your neighbor what the Y-intercept represents, and tell him what the X-intercept represents. Let's see. If we get this right, we're done. If not, we're going to do the next one together. Let me pick Brian. Brian, what is our Y? What does the Y-intercept represent? Yes, I just need to finish this. That is correct. That's the distance of the race. And what is the X-intercept? The time, thank you, it takes for me to finish the race. Your home plate for tonight is on page 168. Make sure you put away your iPad on your way out. Have a good one, guys. Enjoy your home plate. See you guys tomorrow. Bye.